Uniformly accelerated linear motion. What is uniformly accelerated linear motion? Well, this is motion with a constant acceleration. So any motion, any movement that has a constant acceleration is called uniformly accelerated linear motion. Usually we're going to be dealing with uniformly accelerated linear motion. We're not going to deal with non-uniformly accelerated linear motion. Maybe when we will be doing graphing, we can work on that, but usually we work with uniformly accelerated linear motion. So just know that this is motion with a constant acceleration, with an acceleration that is not changing. If the acceleration is 10 meters per second squared, then it will be 10 meters per second squared throughout the journey. So there are three equations which are used for studying such kind of motion, and they are called equations of motion. The first one is v is equal to u plus at, where v means final velocity, u initial velocity, a acceleration, t time. So this equation, if you look closely, is the same that we have discussed on acceleration, like the formula for getting acceleration, which is v minus u over time. So it has just been rearranged such that v has been made the subject of the formula. So if you encounter questions like the one we have just discussed, just know that you have to apply this formula. But don't worry, there is a way to tell which formula to apply. The second equation of motion is s is equal to ut plus half at squared. S, I know s is for distance. We have been using d for distance and displacement, but now we'll be using s for distance and displacement. So s is equal to, which is s is for distance or displacement, is equal to initial velocity times time plus half times acceleration times time squared. And the final one is v squared is equal to u squared plus 2as, where v squared is final velocity, u squared is initial velocity, plus 2 times acceleration times distance. So this is just a summary of the symbols we are using here. V is final velocity, u is initial velocity, t is time, a is acceleration, and s is distance or displacement. I'm supposed to show here. So how do you tell, when given a question, how do you tell which equation of motion to use? So it's not like when you want to use this, then you're supposed to find final velocity, and this you're supposed to find distance, and this you're supposed to find what? Anyway, it depends on what you have been given. If, for example, the question says a car had an initial velocity of 10, acceleration of 10, and time and the time it took was 1, then you have been asked to find the velocity. You can use this. You have been asked to find the final velocity. You can use this or this because they both are final velocity, but you have to ask yourself which one has all the information I've been given. So I've been given initial velocity, acceleration, and time. So you have to use this one, because if you use this one, you're going to have an issue with distance. This one requires you to have distance. So that's the way to use the equation. And note that you can use this equation to find initial velocity, to find acceleration, to find time. You can also use this equation of motion to find distance, or maybe to find initial velocity or time and acceleration. For example, if you have been given a question which says a car had a displacement of 10 meters, and a car had a displacement of 10 meters, and it accelerated at 5 meters per second squared. Given that its initial velocity was 10 meters per second, what time did it took to cover the journey? So a car had a displacement, it accelerated in seconds time. So everything here, time has been given. The only thing that you don't have is this. So if you have been asked to find the initial velocity, then you use this, because if you try the others, you're going to miss out some information. To understand exactly what I'm trying to say here, let's take a look at examples. So example 1. A fly flew for 10 meters per second with an acceleration of 2 meters per second squared for 5 seconds. What is its velocity at the end of the 5 seconds? So this Mr. Fly here flew for 10 meters per second. So this is the speed with an acceleration of 2 meters per second. So this is acceleration for 5 seconds. This is time. What is its velocity at the end of the 5 seconds? So at the end of the 5 seconds, which means they're talking about the final velocity. So the first thing that you do is you write down what you've been given. So the given data is we've been given the initial velocity, which was the velocity it was flying with, which is 10 meters per second, and acceleration is 2 meters per second squared, and time, these are the parameters they have given us. Time is 5 seconds. So we're looking for what? We're looking for velocity at the end of the journey, which is final velocity. So on the equations of motion, which equation has initial velocity, acceleration, time, and final velocity. So we take a look at the equations of motion. Which one has u, a, t, and v? So if we take a look at the first one, it has v, it has u, it has a, it has t. So this one has everything we need. So we're going to use the first one. So this is the equation. V is equal to u plus at. We plug in the values that we have been given. So final velocity is equal to initial velocity, which is 10 meters per second, plus acceleration times time. So if we punch this, we're going to have 20 meters per second as our final velocity. Another example, a car started from rest and accelerated at 2 meters per second squared in 10 seconds. What is its velocity at the end of the 10 seconds? So there is an important thing that you should learn from here. It's very important. A car started from rest and accelerated at 2 meters per second. So if something started a journey from rest, what this means is its initial velocity is 0, because from rest, which means it wasn't moving, so its initial velocity is 0. Even the other way is when a car is moving, then it comes to rest. If it comes to rest, it means its final velocity is 0. But in this case, it started from rest. Therefore, the final velocity is 0. So a car started from rest, which means the final velocity is 0, and accelerated at 2 meters per second squared. Acceleration in 10 seconds time. What is its velocity at the end of the 10 seconds? What is its velocity at the end? Working for final velocity. So what is it that we have been given? So started from rest means initial velocity is 0. Acceleration is 2 meters per second squared. Time is 10 seconds. Looking for final velocity. So again, on the equations of motion, I think we're going to use the previous one because the parameters are the same. So we're going to use this. The only change is initial velocity is going to be 0 because of the word rest. So v is equal to 0 meters per second plus 2 meters per second squared times 5. I've just plugged in. So when you calculate this, you're going to get 10 meters per second as the final velocity. The third example, a plane was flying at the velocity of 10 meters per second before it accelerated. It accelerated at 2 meters per second squared. This is supposed to be second squared in 5 seconds. What distance did it cover? A plane was flying at a velocity of 10 meters per second before it accelerated at 2 meters per second squared in 5 seconds. What distance did it cover? So again, we write down what we have been given. So the given data, we have initial velocity, which is 10 meters per second. We have acceleration, which is 2 meters per second squared. We have time, which is 5 seconds. The question is, what distance? So which on the equations of motion, which one has u, a, t, and s? So if we take a look at the first equation of motion, which is v is equal to u plus at, we're going to realize that this one has no distance in it, so we cannot apply it. What about the second one? So this one has distance. What about the other parameters? Does it have the other parameters? So initial velocity, yes, this one has it. What about acceleration? Yes, this one has it. And time, this one has it. So we can use this one. What about the third one? Maybe there's a mistake here. What about the third one? The third one has distance, which is okay. Does it have initial velocity? Yes, it does. Does it have acceleration? Yes, it does. Does it have time? No. So we cannot use it. And it needs final velocity. We don't have final velocity, so we cannot use this one. The only one that will work is this one. So we can plug in the values. So we're going to have s is equal to initial velocity, which was 10, times time, which is 5, plus half, times acceleration, which is 2, times time squared, which is 5 squared. So when we punch this, we're going to get here, we're going to get 50, and the other side, we're going to get 25. 50 plus 25 is going to give us 75 meters. So that's the distance it covered. The final example, a lizard was running at a velocity, at a certain velocity, and changed its velocity to 10 meters per second with a uniform acceleration of negative 2 meters per second squared, covering a distance of 10 meters. What was its initial velocity? So this lizard was running at a certain velocity, which we don't know. Then it changed its velocity to 10 meters per second with a uniform acceleration of negative 2 meters per second, covering a distance of 10 meters. What was its initial velocity? So this velocity, which they haven't specified, is the one we're looking for. So what data have we been given? So the given data, the final velocity is 10 meters per second. Then the acceleration is negative 2 meters per second squared. The distance it covered was 10 meters. So we're looking for initial velocity. So which equation of motion are we going to use? So if we look at the first one, velocity, final velocity, yes, we have acceleration. We're taking from here. So final velocity, yes, we have acceleration. Yes, we have distance. We don't have. So go to the second one. Final velocity, we don't have. So this one is disqualified. We go to the third one. Final velocity, we have acceleration, we have distance, we have. We're looking for what? Initial velocity, we have. So this one is the one that we're going to use. Other than just knowing that this is the one we're going to use, there's another skill that I want to demonstrate here. So all of them that we have done so far, we're looking for this and this. But this time, we're looking for initial velocity, which is this. So you have to solve for initial velocity. There are two ways to go about it. You can make initial velocity your subject, then you plug in. Or you can just plug in and start solving for initial velocity. So v squared u squared plus 2as. So we can plug in the values. So v squared is 10 squared. Initial velocity is the one we're looking for, plus 2 times acceleration, which was negative 2, and distance, which is 10. So here we're going to have 100, and here we're going to have 2 multiplied by negative 2 is negative 4, times 10 is going to be negative 40. So we're going to have this 100 is equal to u squared negative 40. Next, we take negative 4 the other side. This, when it crosses the equal sign, it becomes positive. So we're going to have 100 plus 40 equals u squared. 100 plus 40 is 140 u squared. How do we get rid of the square so that we just have u? We square root both sides. So when you square root, these two and the square root are going to cancel. And here, square root of 140, if we have a calculator, we can punch, and we're going to get 11.8 meters per second as our initial velocity. 11.8 meters per second. So these are all the necessary skills you need to deal with uniformly accelerated motion. It doesn't get more complicated than this. In the notes, there are, for those with access to my notes, in the notes there are even more examples so that you practice. If you do more examples, you'll be able to tell what equation to use when. So this marks the end of this subtopic. Make sure you like, subscribe, and share if you are watching on YouTube. Otherwise, happy solving.